All right, guys. So I told you on yesterday's post that I was going to do a problem from some of the dimensional analysis review that that I gave you in class. So the heading of this paper is dimensional analysis review. If you're trying to figure out where I'm at, and I am on A, B, C, D, E, F, G1. Okay, so G1 is where I'm at, and I'm just going to go ahead and take you through the process of basically how to find formula mass, how to convert grams to moles, and then moles to moles is going to be today's video, because that's kind of some of the type of work that you're going to have to be able to do on the quiz next week. And hopefully that the more and more of these videos you watch and the more example problems you see, you'll be able to catch on yourself. But still, please email me if you have a question, and I can try to type up, how to do certain problems. So I just try to communicate with me and I can try to help you out. So anyway, first step, okay, if you guys remember, is always, always, always write the knowns and unknowns. So in this case, the given is 45 grams of HNO3. And we are supposed to put them over 1. Okay, if you guys remember that from class, I said always try to put it over 1. So we got 45 grams HNO3 over 1. Okay, so then you're supposed to convert to moles, right? So if you look at your mole chart here, that will help you a lot. We need to go grams to moles, so I'm going to have grams on the denominator here. Okay. And these units are going to end up canceling because they're the same. Remember, we always said if units are opposite one another, you will cancel them. This is going to be moles of HNO3. And anytime you're converting from grams to moles, if you guys look at your formula or your chart that I gave you, it's always 1 mole over the formula mass. So in this case, you'll notice that there's one thing that we're missing. So right here, the formula mass of HNO3, it's not just given, right? So what you're going to have to do is you're going to have to find it. So I'm going to use the periodic table and try to do that. So I know that H is 1.01 if you round to the nearest hundredth. Remember I said try to round to the nearest hundredth. So, okay, H, and there's only one of them in HNO3, so you only have to do it once. So 1.01. That's grams per mole. Do not forget to write units. Okay, that's extremely important that you put units. For N, okay, if I go back to the periodic table, it is 14.01. If I round that, there's only one of them. Okay, and then for O, if I go back to the periodic table, O is rounded. I'm just going to round that to 16.00. Okay, and that's going to be times 3 because there's 3 O's over here. Okay, so right there, there's 3. It's multiplied by 3. All right. So O, 16. I'm going to put a little 3 here. So for O3, it's going to be 16 times 3 of them, which is going to end up coming out to 48. Okay. So then the last thing is you're going to add these together, 1.01 and 14.01 and 48. So I'm going to go ahead and pull up the calculator here so you guys can see me do that. Internet is moving very slow. There we go. Okay. So 1.01 plus 14.01 plus 48 equals 63.02. Okay. So if I go back over here, that is the value you're going to plug in. So these are going to cancel, the H and the NO3, and then you're going to do 45 divided by 63.02. So if I go back to my tab calculator, Okay, 45 divided by 63.02. That is, we're going to say 0.71. Okay, so we go back over here and we're going to say equals 0.7. Oh my gosh. 71 moles of HNO3. Okay. Now that's not your final answer because if you scroll up, it asks you for moles of H. So at this point, this answer right here, 0.71 moles of HNO3, you have to convert to moles of H by itself. So, excuse me, the last step is I'm going to go ahead and plug in 0.71 moles of HNO3 over 1 now. And I'm going to convert to moles. So you always want to have the same unit on the denominator of the next one you're converting. So right here, this has got to be HNO3. Okay, so that cancels. And then this is going to be moles of just H. I don't know if you guys remember, because we haven't done one of these in a while, but anytime you're going from moles of the compound, so right here, moles of this to moles of this, you simply look at the subscripts, okay? Subscripts are these numbers, so like this 3 right here, okay, on the O, that's a subscript. So if you look at H right here, there is no subscript, okay, and that means it's just a 1. So all I'm going to do is put a 1 right here. There's 1 for 1, which means it's the same answer, okay? So technically I can go back up here and I can just say, okay, you know, my answer is also for this whole problem. You know, I'll make this in red, just make it our final answer. It is 0.71 moles of hydrogen. And that is it. Okay. So that right there, you know, if I box it in, that's my answer, the 0.71 moles of H. Okay. Anyway, that is it for that stoichiometry problem. Hopefully that'll help ring a bell and get you guys started back on doing these types of problems. If you didn't watch the quiz review video from a couple days ago, please watch that. It will definitely help you next week with being able to figure out some of those problems and get us head start on them. But anyway, that's it for today. I will try to, well, I'll probably just tomorrow start reviewing more content. I might do a multiple steps practice or another one that has to do with molecules to moles. So you'll see that as well. Anyway, have a good rest of your day. Signing off.